the 3 states of matter. We have read that matter can exist in 3 different states: solid, liquid, or gaseous. We'll take the example of water to discuss the various states of matter. The water that we drink exists in the liquid state. The molecules that constitute water are loosely packed, and only mild intermolecular forces keep them together. In a state like this, water has a fixed volume but no definite shape. It takes the shape of the container that it is poured in. Ice is water in the solid state. Here the molecules are closely packed and arranged in a manner that they have a fixed volume and shape. In this state, the substance is at its densest. In the gaseous state, called water vapor, water molecules are furthest apart, with hardly any force keeping them together.
It is important to note that the steam we see with our naked eyes is not a gas. It is mist consisting of liquid water particles. The region between the visible steam and water is where we find water vapor, which is a gas.
In this state, a substance has a very low density. It distributes uniformly and spontaneously to take the shape of any container. The temperature of a material indicates its physical state. Let us take the example of water again. The temperature at which liquid water changes its state to become solid ice is called its freezing point. The freezing point of pure water is 0 degrees Celsius at standard atmospheric pressure. Similarly, the temperature at which solid ice changes its state to become liquid water is called its melting point. Under the same conditions, the melting point and the freezing point of a substance are the same. The temperature at which a liquid starts to boil is called its boiling point. It is the temperature at which the vapor pressure of a liquid equals the atmospheric pressure at sea level. At standard atmospheric pressure, the boiling point of water is 100 degrees Celsius. Given that the melting point of solid water is 0 degrees Celsius, in what state would water occur at 25 degrees Celsius at standard atmospheric pressure? We can see that it would occur as a liquid. Similarly, at 110 degrees Celsius at atmospheric pressure, pure water should be a gas, since the temperature is beyond its boiling point of 100 degrees Celsius. We know that liquid water evaporates to form water vapor. So, how is evaporation different from boiling? Evaporation occurs at temperatures below the boiling point. It takes place at the surface of a liquid, where molecules with high kinetic energy escape to form vapor. It happens all the time over water bodies on the surface of the Earth due to the heat from the sun's rays. Boiling is the formation of bubbles of vapor within the water. The vapor pressure of a liquid at boiling point is sufficient to overcome the atmospheric pressure, causing the bubbles to form. When evaporation happens directly from the solid phase, it is called sublimation. It means that a solid changes state to directly become a gas, without becoming a liquid first. Sublimation can be seen in dry ice and naphthalene balls. Condensation occurs when the physical state of matter changes from gaseous to liquid. It is the reverse of vaporization. Water vapor condenses at high altitudes to give liquid water, which falls as rain.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you. Anytime, anywhere.